Can humanity thrive on the moon? Not merely survive, but truly enjoy life within a community they can call home. The desire to set up research stations along mining and manufacturing operations on the moon is something many might have found long overdue. Due to its harsh conditions, the moon has always been viewed as a research destination rather than a place for permanent living. There are no cities on the moon right now, but what if we could change that? Could we take steps to make the moon slightly more welcoming for human life? Is it possible that the moon could become a place we call home in the future? Let's see what life in a lunar colony will be like. Elon Musk recently came up with an interesting idea. Building a self-sufficient city on Mars would be possible if we could get 1 million tons of supplies from Earth. Although this sounds like a huge job, we can definitely handle it. If Musk's plan to build 1,000 Starship rockets comes true, each one would only have to carry 100 tons of cargo 10 times. There is a transfer window to Mars every 2 years, and the trips take 6 to 9 months. This is the biggest problem. This mission could last for decades based on how long it takes each Starship to go back and forth. But in the meantime, SpaceX might make even more advanced starships. Putting together a city on Mars will take many years and even generations. But let's look at the moon. Before we do that, I'd like to give you a few seconds to subscribe to our channel if you appreciate our content. Now that we're past that, let's talk about the moon. Musk is happy about NASA's contract to land on the moon, but he seems more relaxed about settling down on the moon. For now though, the moon has potential. If Mars needs 1 million tons of stuff, the moon might need the same amount, even though it's smaller. Because the moon is so close to Earth, missions could go there much faster than Mars, where trips take a long time. Round trips only take 4 to 5 days. Because of this, the project could be finished in a lot less time with a smaller fleet of ships. But the idea of quickly packing up and sending off so many missions seems like it would be too much. Fewer ships making multiple trips might be a better way to go about things. Any way you look at it, getting our goal of sending 1 million tons of stuff to the moon would definitely be faster than taking a single trip to Mars, which starts to make sense. Although this is true, Elon Musk is still focused on Mars because the moon, even though it's close, has its own problems. We have to deal with the moon's huge temperature changes. Temperatures drop to a bone-chilling -280 degrees Fahrenheit, or -175 degrees Celsius at night, and soar to a scorching 260 degrees Fahrenheit, or 126 degrees Celsius during the day. Also, a day on the moon is the same as 29.5 days on Earth. So people are exposed to the same extreme temperatures for a long time. People know that computers and heat don't get along well. So this is especially bad during the lunar day when cooling systems have a hard time working. On the other hand, Mars is mostly cold, though it does get to a more manageable 70 degrees Fahrenheit or 20 degrees Celsius every once in a while. So if we want to make the moon a good place to live, these are the important issues we need to deal with. Insulation is very important for making places on the moon habitable. The idea of a dome that lets people look into space is interesting, but it will take a lot of work to find a material that can effectively block heat while still being practical. Either this stuff would have been brought from Earth, or it would have been made on the moon, both of which would be hard. A better plan might be to build settlements that are low and close together and then cover them with lunar regolith, which is the layer of dust, small rocks, and other particles that cover the moon's surface. A thick regolith layer is a great insulator, and mixing it with a binding agent can make a material like concrete that is even better at keeping heat in and lasts longer. Beyond insulation, this covering must also shield against meteorites and solar radiation. On Earth, our atmosphere provides this protection, but the moon's extremely thin exosphere, with only about 100 molecules per cubic centimeter compared to Earth's 1 billion, offer minimal defense. Furthermore, the moon lacks a magnetic field to repel solar wind, a significant disadvantage in maintaining an atmosphere. Mars, while also having a thin atmosphere, is better positioned than the moon in this regard. Its greater size and gravity could potentially allow for atmospheric densification at a rate outpacing solar wind erosion, a feat unimaginable on the moon. Gravity presents yet another hurdle. Its weakness on the moon might not just challenge the retention of an atmosphere, it could also affect human physiology. The moon's gravitational pull is merely 15% that of Earth's, which is about half of Mars's gravity. What implications does this have for human health? It's a complex issue. Valery Polyakov, a Russian cosmonaut, held the record for the longest continuous stay in almost zero gravity, which was 437 days in Earth orbit. The point of this experiment was to see what happens to the human body when it is in microgravity for a long time. Surprisingly, Polyakov came out of this experiment without any long-term or negative health effects. His experiment makes me think that it might be possible to live in a city on the moon as long as we take steps to protect ourselves from the environmental hazards and keep a close eye on how low gravity affects our bodies over time. Unlike a journey to Mars, which requires a minimum of 2 years on its surface plus the travel time, lunar missions offer more flexibility. The effects of extended stays on Mars remains unknown, and once there, leaving prematurely isn't an option. But the moon might require only a short habitation to sustain a human presence. Rotating 1-year shifts could be a practical approach, allowing inhabitants to live there temporarily without adverse effects. The relatively short travel time to and from Earth, just a few days, adds to the feasibility of such rotations. The case of reaching the moon is somewhat amusing when compared to other human endeavors. Crossing oceans by boat takes weeks, while circumnavigating the globe in a jet can take about 60 hours. A rocket journey to the moon only takes about 3 days. In the Star Trek movie First Contact, Captain Picard mentions over 50 million people living on the moon by year 2373. Considering the moon's vast surface area of about 15 million square miles, or 38 million square kilometers, accommodating 50 million or even more individuals comfortably is entirely plausible. For perspective, Asia spans over 44 million square kilometers and houses around 5 billion people, highlighting the potential for substantial lunar habitation within the next 300 years. So how can we make lunar habitation possible? By ensuring the essentials: air, water, food, and power, the prospect becomes quite achievable. Interestingly, we can source oxygen directly from the moon's surface. On average, each cubic meter of lunar soil, known as regolith, contains about 1.4 tons of minerals, which includes roughly 630 kilograms of oxygen. Considering NASA's estimate that humans require approximately 800 grams of oxygen daily to survive, this means a single person could live off the moon's oxygen supply for nearly 2 years, a fascinating concept indeed. To extract this vital oxygen, we can employ a technique known as electrolysis. Moreover, the moon offers a viable water supply. Craters on the moon likely harbor water ice brought by asteroids and preserved in perpetual shadow. Additionally, heating the lunar surface can release water vapor from the regolith, which can then be captured and condensed into liquid water. And yes, recycling urine into drinkable water is a practice method in space. While it may not sound appealing, it's a practical solution for sustainable living off Earth. Moving on to food, NASA has found that over time, the dried food that comes in a package loses important nutrients. These foods can give you the calories you need, but they don't give you enough of the vitamins you require. This makes you more likely to get vitamin deficiencies like scurvy, which is something we want to avoid on the moon. The answer is to grow fresh foods that can come from plants. Leafy vegetables has been grown successfully on the International Space Station as a part of an ongoing NASA experiment. This shows that it is possible to grow fresh, healthy food in space. Also, the technology we use will be very important, especially when it comes to communication. Staying connected is important for both sending and receiving important information and keeping people on the moon happy. To keep people on the moon feeling connected to people back on Earth, it's important to let them use video calls, live streams, and other digital tools. This is why SpaceX's Starlink project is so important. SpaceX plans to test a laser-based communication system on its Starlink satellites during Polaris Dawn, a high-altitude orbital mission in late 2022. The goal of the mission is to send a Crew Dragon capsule to the highest Earth orbit that has ever been reached. From here, they will test the new optical laser features of the Starlink network in order to make high-bandwidth, low-latency communication possible between Earth and space. If these tests go well so far, it may be possible to build a Starlink network around the moon that connects to Earth. For power generation on the moon, solar energy is an obvious initial choice. But NASA is also exploring the potential of miniature nuclear reactors as mobile power stations for a longer-term solution. An intriguing possibility is the exploitation of helium-3, an isotope abundant in lunar regolith, generated through solar radiation absorption. This element, scarce on Earth due to our protective atmosphere, could potentially fuel power plants efficiently. It's estimated that just 100 kilograms of helium-3 could power a small city for a year, and the moon has an ample supply. So, is the moon a more viable option for colonization than Mars? It does possess several unique advantages that warrant consideration. Don't forget to share your thoughts and theories in the comment section.